Welcome back, everybody. My name is Manfred and you are watching Abstract Live. It's a wonderful day here. I'm happy to be back with you guys. There's a lot of great things that we're going to be talking about today. I hope it's not going to be as spooky as it was last time with those random hiccups during the stream, but overall I think it's going to be super interesting. And there's a couple of news for us to talk about today, so maybe let's transition right to the latest breaking news that we have for you today. And I'm going to take off these glasses here. I can finally see again. All right, guys. So first off, don't forget to like, subscribe, and hit the notification bell, guys. This is really important. It helps us tremendously when it comes to surfacing our content in the YouTube universe. So don't forget to hit like and subscribe. And then also we have been, I mentioned it last time, November started and we're in the middle of November. So if you haven't already, make sure to create some awesome materials and then share them on X. Share them on Polyverse. If you haven't seen Polyverse yet, it's worth checking it out. It's pretty awesome. And speaking of Polyverse, actually, we have done another fantastic material drop. The team has been working hard to add more materials. So if you use Polyverse, you get a lot of materials for free. The team regularly updates and adds new materials to the library that you can just use, download, build upon here on Polyverse. And these are really nice looking materials, very detailed. Like this.
Yeah, I really like this drop. This just drop is really versatile. You know, you can use it for anything from like walls to, you know, actual, you know, product material finishes, things like that. It's very, very cool. And these really cool smooth and reflective surfaces that you can just go ahead and download and check them out. And also you can view them in AR as well. This is pretty cool. If you want to see how these materials are going to react in a certain environment, if you have an iPhone or iPad, you can very easily just click the AR button and then it will show up on your desk, you know, as a material sphere. It's pretty awesome. Yeah,
you do need an iPhone though. I can't do this on my MacBook right here, but if you have an iPhone, you can just click on a button and scan it, and there's nothing you have to install. It should just work out of the box. And I do agree. I think these materials are great for products and product visualization, right? You have a lot of different nicely colored plastics and metals, so this should be a great fit if you want to do some material renders. Looks pretty great.
Very, very cool. Yeah.
Fantastic. And it's also very browsable, guys. So you have all of these drops where you can open a drop and then you find all of the materials inside of it. And you can even, if you have a Polyverse account, one of the nice features that I like, if I find something I like, I can just add it to my own collection here by clicking on the plus button, and then you can choose one of your libraries and you get a local copy inside of your library. So you'll always be able to find it, create your own drops, create your own collections. It's a pretty nice feature.
Absolutely. There's so many different materials in there as well, from flooring to, you know, wood to it's really diverse. And the fact is you can easily just search through all the materials as well from the main, you know, screen there inside of Polyverse. And so, yeah, I highly recommend checking out, you know, all the different materials that you can use right now today for free.
Absolutely. And another big change for us is that we have changed our Twitter handle. So we're no longer at the abstract_co. We are now finally rightfully own the name Abstract 3D at X, which is pretty nice. So that's one of the bigger changes here. If you want to speak to us, make sure you tag us rightly. As you can see here, share your new handle. This is pretty much breaking news. There's more. Even on the weekend it leaked. There was some when the demo version for Kirby Air Riders got released by Nintendo. There's like an open preview, an open beta on this weekend. I'm not sure if it's still running actually. But what people found is if you open the license screen, you can see that they actually used InstaMAT for the production of Kirby Air Riders, which is pretty awesome. It's a first-party Nintendo title. I'm really excited to be checking that one out. I currently don't have a Switch 2. I only have a Switch 1. So I would need to get a Switch 2. Do you have a Switch 2, Jeremy?
I have a Switch 1. I wasn't sure if it was just exclusive to Switch 2.
It's exclusive.
It is. Bummer. Okay, well there's my excuse now. I can say it's for work, of course, and start playing some Kirby Air Riders.
Yeah, I mean that's a tricky part, right? They do want to sell more Switch 2s, and if they would make it available for Switch 1, people probably would be less likely to upgrade. But given the fact that they do this, it has to be an important title for Nintendo. Pretty great that we're part of it.
A huge major character for Nintendo. It's really awesome to see InstaMAT be a part of it.
Yeah. I actually didn't know this, but the guy that made Smash Brothers is the same guy that created Kirby, which explains why you have the character in Smash Brothers.
Right. Wow, yeah, and talk about one of my most favorite games ever. I've been playing that all the different versions of Smash Brothers through the years since, Nintendo 64. It's been really great.
Yeah, and Kirby has been around for so long. I remember even on the Game Boy and Nintendo, you had Kirby games. Like, this character has to go back a really long time. Like, it always, for me, it was always around like Mario, right? It's just one of the standard characters.
Yeah. It's really cool to see that. Yeah, and to have amazing, characters like Sonic and Kirby and all this, being able to utilize Instalot. It's such a nice way to see a bunch of different really powerful characters and games using the technology. Actually,
also why this leaked is because they use their own game engine, which is also pretty nice these days, right? Most people use stock engines. I mean, I don't mind it. We're building RSX engine, which is also a standard, tool like you would use Unity or Unreal Engine. But it's nice to see when game devs still bring their own engine, because that means they're really committed to building that technology and making something that's different. And it's actually got leaked from this Japanese website here, where they found that they're using their in-house game engine, and they recognized it by the name Sol Avis. And then they posted basically the receipts for it, and you can see that Instalot is also part of the same screenshot. So they listed right next to the name of their engine, which is pretty cool.
Wow, that's pretty awesome.
Yeah,
those leaks, man.
Yeah, absolutely.
Very, very neat.
Thankfully, we don't have leaks, but what we have is InstaMAT here running in the background, and that brings us to the next topic, guys. We had a couple of questions: how you can do animations, how you can keyframe content. Is that possible with InstaMAT? And it absolutely is possible. We didn't do a lot of video material on it yet because there's still so many other primary features that we have to cover, but we wanted to take a few minutes today to show you how you can use the dope sheet in InstaMAT to animate your materials or to build something like a turntable render. So let's get right to it. So let's assume that I've built a material, and we can just take one of our library. Which one should we take here? What's a nice
good
material?
Ones to choose from. I mean, I always default to the lava material, just because it has that neat emissive kind of properties, but also some reflective materials could look pretty nice as they reflect the environment.
Yeah, I think the lava that's good enough for me. So let's just take that lava material here. And if we preview it on our cube, you guys can see how that looks. So this is how it looks with its default settings. I think we have to turn down the displacement just a little bit, so let me do that. Going into the...
Yeah, this one I think just came from our latest InstaMAT update as well. It's one of my favorites. It's got some pretty cool parameters where you can adjust the oozing of the lava on the surface. It's very nice.
Yeah, so it lends itself pretty well to doing this kind of animation thing where we keyframe some parameters. And the way that this would work is that any parameter that you expose in your graph can be keyframed. So let's take a look at some of these parameters here. For instance, we have the cracks here, the lava, the glow of the lava. Yeah, so we could make the lava glow more. And I'll turn down the resolution here just to render the material a bit faster. So we have the lava here and the flow, it seems.
Yeah, that one's definitely my favorite.
Interesting. Right, so if you want to render this material out, what you would have to do is create parameters, because that's what the object that would ultimately get animated through your graph. So to do this, we would need to expose our lava flow parameter if that's what we want to animate. So we right-click, choose to expose. And just for good measure, I'm going to expose the material outputs here so I don't have to manually always activate the preview on our viewport. Like this. And then if you want to animate the parameter, it's actually super easy to do. All we have to do is open our dope sheet. So this button right here opens the dope sheet, and you can see it here at the bottom. And the dope sheet basically contains all of the parameters that you animate and the information about how you would animate the parameter over the timeline. So you can see you have all of the different frames here in your animation, and I can zoom. And you can see that we have 600 frames in our on our dope sheet. I think that's enough, but you could always change duration or drag the blue slider up here, which would indicate the size of your animation. Right, so if you want to animate the lava flow parameter that we exposed here, all we would have to do is right-click on our parameter here in the graph object editor on the right side, and then right click here, and then here we can have this option, add a keyframe to the dope sheet. So if we do this, it's going to take the current value of your parameter and then add it to the dope sheet to be animated. So if I right click here and add the keyframe, you can see that it's adding the entry here, and it's also adding the scalar row, which will then basically represent the value of that particular point in time. So if I go to the end of the let's do it in order. So I go to the middle, and in the middle of our animation, I want the lava flow to be at the highest value. So all I have to do is I'm going to change the slider to be at 100%, right click and add a keyframe here. And if we look at the scalar here, you can now see exactly how the animation would interpolate. And if I move my slider, what's pretty nice is that you can see InstaMAT is updating in real time as I'm dragging the slider. So this is actually also pretty cool if you want to, if you don't want to render the animation, but you want to preview or see how different values behave in combination. You can then basically set your different values and just, slide around on the timeline, and you'll see what happens locally on your material. Right, so
yeah, I also like that it gives this really nice interpolation by default as well. It does this really nice easing curve. For those of you that are familiar with animating, a lot of applications will do this kind of linear interpolation between one point to another, and it's very jarring to have something move or change, directly at the beginning or in a certain direction. So this is doing a nice, what is it, Bezier? I forget what type of interpolation it is by default, but it's doing a nice smooth in and out easing for you by default.
Yeah, so it's doing an ease in, ease out easing on the curve, and it's using Bezier curves to do that. So you can always change that. So if I want the value to be more steep and fast at the end, you can just move it down, or you can pull out the handle if you want to quickly go to the end value. So this gives you a lot of configuration. It's a pretty nice UX here to set up these animations. So, but I want this to be looping. So right now we basically go from 0 to 300. And then the video wouldn't be looping, right? Because it would then be stuck at 300 here, and then it goes back to the beginning, and it's instantly at 0 again. So if you want to create a looping animation, we would have to go all the way to the end and then set the value back to 0 and then add a keyframe here. And you see what it does now. The value goes up, then it's at the max value, and then it goes down. It's actually pretty nice that you also can hover over your value curve here, and you can see the value being visualized in this small pop-up here.
Yeah, really nice. And it's pretty cool that you can see the parameters, automatically adjusting right within InstaMAT as well. It's a great way to sort of diagnose, if something looks good in between the animation, and maybe you want to set that as like a default. It's a really handy tool, not just in creating, kind of movies or clips or things like that, but also a great way to, just like you were saying, do some previews and see the kind of variation in scope of the different materials.
Yeah, and as you guys can see, it's already playing and looping, which is pretty nice. And you don't have to use this material. This is not baked on the material. So I can also use another one of my favorite materials, which is this thermal insulation material here. So we just change the material, and let's quickly replace the parameters, just relocate the connections here, base color, the normal channel, roughness.
Just as a quick note, you can also use the link category mode to very quickly change those as well. I always want to save time as much as possible.
That's true. That works. There's many roads that lead to Rome. So I've changed the material, and you guys can see it here. And there's also an interesting parameter that's worth animating. It's called, what is it called? Inflation or something like this. So here we have the deflate parameter. So if I change that here, you see now it goes inside and now it goes outside. So it's also very, very visually interesting parameter to interpolate. So we can just take our parameter and then reconnect it to, if I'm able to locate it, there it is, the deflate amount. So we plug this in here. And if we play back our animation, you guys can see that hopefully these shapes, these patterns now inflate and then they deflate again. It looks pretty cool.
Yeah, it almost looks like it's breathing. It's
yeah,
pretty neat.
I really like this material. So, and you're not limited to doing just one parameter that's being interpolated here. So you could always go in and then control more parameters. Which one could be interesting to interpolate here? maybe the fold opacity, that actually makes sense, right? The more it's inflated, the more or the less you should see the folds, right? So when it's not inflated, we should have this at 100%. And then once it's inflated, we should set it to 0%. So let's try that. I'm going to expose the parameter. I'm going to collapse the node again. And let's see how we can do this. So we have the fold opacity, and remember in the beginning it's deflated, so we set the fold opacity to 100%. Add a keyframe here. Go to the middle part, reduce the folds, add a keyframe, go to the very end of our timeline, and then once again set the fold opacity to 100%. And if we animate this now, I'm not sure if you guys can see that in the stream, but as we now inflate those shapes, the folds go away, which looks pretty cool. And then it shrinks back down and the folds become more visible. That looks pretty cool. Awesome.
So how are these animation parameters saved? Where are they saved? Are they saved inside of the InstaMAT, or are they saved with the graph? How does that work?
That's a pretty good question. I mean, who really knows where those are saved? No, all the jokes aside, those are actually saved in your graph. So this graph right here contains all of the information when it comes to your animation. And we're going to make more use of this information down the line. For instance, when you would use the material in a renderer, we could not just bake out the material, but we could bake out a sprite sheet, for instance, of your material, or do more interesting things with it. But rest assured, this is not just something that's transient or that happens within the current session, and when you close your session, it's gone. It actually sticks around. It's saved in the graph. So whatever you do here, it's saved. But that's also the reason why when I do these animations, I typically don't do them in the material itself. I always create like a wrapper graph, a wrapper project, instance the material, and then animate the parameters like this.
Right.
Okay, so what else can we do here? So now imagine you want to actually render this as an animation, and you use what do we use here? The hemisphere. What's going to look good? Let's try it again.
Yeah, usually when I use the hemisphere, I like to tile the material maybe twice on the UVs just to get a little bit of extra detail in there. Depends on what you need for the material.
Yeah, let me see. I think it doesn't look as cool. If on 1x you see the inflation way better, so I'll keep it on 1x. But if you want to render this out, and I hope my MacBook won't be unhappy that we do video encoding while we do the screen share here, but to render this out, you can click on this little camera button right here, and there's a feature, playback capture. So if you enable this, it's going to store anything that happens in your viewport once you hit play. Basically, you can render out your capture as a small video. So if we hit play, you see it's now recording the animation. That might take a little bit. But what's nice is when you do this, it's similar to encoding or saving, rendering your video when you use a tool like Final Cut. There won't be any missed frames, so it's going to be a perfectly smooth animation once it finished exporting. So that's a pretty cool feature to create beautiful turntables without having to leave InstaMAT and setting up a scene in Maya and then doing all of that in Maya. But how would you even do that, right? How would you inflate and animate your material within Maya where you would do that kind of compositing? Or if you would use Marmoset, you couldn't, because then you would be limited again to having a static bake of your material, which wouldn't allow you to do these dynamic animations. So it's a super powerful feature to make sure your material looks as good as it possibly can, showing off all of the wide range of different configuration options you have for the material. It's still rendering.
Yeah, that's great.
Yeah.
I was just going to mention, once you set up your scene, as it were, as your settings for doing that turntable or adjusting the material settings, then you can just reuse this element graph over and over again to create consistent turntables with the lighting that you need, all that kind of stuff. So it's a very reusable and scalable way of working too.
Absolutely. We should probably have like a template project for this. Right?
That would be really cool.
That would be a nice addition to have a template, and people can just drop in their own material and everything would automatically be working in their favor. So it finished rendering. So let me see here's the video actually. So if we open this, you can see here we have this beautiful little MP4 file, and I can just hit play and it's rendering butter smooth, 60 frames. a 10-second loop. So if you think about it, it was rendering quite a lot of frames, right? It's 60 frames, 10 seconds, so it's 600 frames it had to render, so it takes a little bit. But what you can see is that it got rendered at exactly the same size as my viewport. So if I put this over my viewport, you'll see this is basically the one-to-one resolution here. So it's exactly whatever happens in your viewport, it would be rendered here. If you enable ray tracing, it would capture all of the ray traced samples, integrate them into the rendering. If you change your IBL, it would exactly look as you've configured it. So how do we get this to be rendered at a different resolution would also be a good question for Jeremy to ask. And it's actually
just going to get there.
It's actually very easy to do so. If you enable the custom resolution switch here, you can just enter any resolution. So if you want to render it at 4K, it's very easy to do so. But I think the duration is a bit long, and also let's just render it at 30 frames. And you see it automatically reduces the number of frames we have on a timeline. And then let's just make it 5 seconds long so I can bounce it out much faster. Then let's rescale our animation clip here like this. Let's apply some changes to our viewport.
Now you might be getting to this in a little bit later, but let's say someone wanted to animate the rotation of the environment or something like that. Are we going to show them that in a little bit?
Yep.
Great.
We are. So I've made some changes to the viewport here, and let's just bake it out again. I think this time it should be pretty fast. So I'm going to hit play, and you can see how fast it exports now, because now it's 30 frames, which means we have 30 frames per second, that is. So we have half the amount of frames, and we only do 5 seconds, so it's like 4 times faster than before. So once it's done, we're going to have another video on our desktop that we can play back.
Now, I believe it does override the video by default, so you need to make sure that you either change the name of the graph or project if you're trying to render out multiple ones.
That's a good point. I lost my previous video. That would actually be a nice feature request to add a timestamp or something to it so you wouldn't override your previous bounds. But you see now it's 5 seconds long and it still looks great. I mean, rendering at 60 frames is probably overkill. I think most of those showcases you might want to render at 30 or maybe even less, so it's more cinematic. I think cinema has some odd frame rate like 24.97 or something like this. But this is working pretty well as is. And can we also animate colors? I think we can, right? So we could.
Oh yeah, absolutely.
So let's try to animate some colors. So I'm going to go to the beginning of my timeline, and we're going to expose the base color here. And to animate, it's basically the same. You just add a keyframe to the dope sheet. I'll add the same color to the beginning and the end because I want this to be looping. Another keyframe. And now I can just go to the middle of my timeline and then have a different color here. So we go from golden to, where do we go to? Silver probably, maybe a bit brighter, like this. And then we add a keyframe here. And if I play this back, we're recording it directly. That's actually, we should also probably add a button or something so you can indicate whether you're capturing, because I actually forgot that we're capturing. I just wanted to preview this. Yeah. Right, okay, so maybe we should have a button that actually does the capture and the bake instead of always capturing on play. That might be a bit nicer for the user. So you guys see we're doing like live product improvements here in the stream. This is really abstract live. It's as real as it gets. So we have our baked out video here, and I open it. Let's make it a bit bigger for you guys. We play this and you see it's transitioning from golden to silver, and then it shrinks. Pretty cool.
Awesome.
I think we can also loop this here, right? Yeah, loop.
Yeah.
So you guys can see if we loop this, it's perfect. So I love these because you can turn them into a GIF, post them on X, share them with your community, embed it with your material in the description. This is a really nice feature.
Absolutely. We really give you a lot of tools to be able to, if you're a developing artist or, trying to share your work out there in many different places, InstaMAT gives you so many tools to be able to present your work right out of the box. And this is just a great way to do that.
Yeah, and let's enable ray tracing. This might slow down our bake a little bit because what it's going to do, it's going to wait until all of the samples have converged. So we can actually improve this, right? If we go to our ray tracing settings here, you can actually reduce the frame count if you don't want to wait so long, especially for video capture. You might not even see the noise in the compressed image. So I've set that to 100, and like every frame that InstaMAT now renders, it has to render 100 frames of ray tracing until it can advance to the next frame that's being captured. So let's keep that previous thing here, and we'll name that no RT, and then we bake it out again with the ray tracing.
Just want to make sure, you know, as you're testing the ray tracing, I know we was mention of a bug occurring with the ray tracing when we're doing the recording of capture. So I don't know if you're using one of the newer builds where that's fixed already, but if people are testing out the recordings with the ray tracing, you might find there's a small bug with the shadows.
You should have told me this before, Jeremy. Oh no,
I did. I promise I did. Yeah. But we're getting carried away with the. It's definitely something.
So great.
You can
I got so excited. So what's the issue then with the ray tracing? What are we expected to see? Because I would have expected that we capture the frame once it's fully converged, but from what you're saying, I believe that we're going to probably capture the first frame, not the fully.
It just does the first frame, which is the noisiest, unfortunately. But it is something that we are aware of and already fixing. It's just I
think it has been fixed already, guys. And I'm just using the release build and not a pre-release build. Otherwise, this would work. I guess then I'll trust Jeremy on this, that this would be a wonky animation and we don't have to wait actually. So this is what it baked. No, it did do it right.
Oh,
Jeremy.
It did it.
Yeah,
okay,
so
well, it's hard to see on stream, so maybe the compression is helping you out a little bit on stream as well. But yeah, great. Okay, good. So, I wanted to save any pain or ghosts and spooky bugs.
Well, I presume this bug has been corrected in the September build, hasn't it?
You know what, that might be it. I might be misremembering from the original release.
I think Jeremy is still in early access mentally, but this guy's this has been corrected.
So long.
Yeah, that's true. Absolutely, we've been there forever.
Awesome. Thanks
but as you guys can see, we bake our animation with these ray traced shadows. It looks pretty nice.
Nice.
If you compare that to the non-ray traced material, which also looks beautiful, but the shadows add quite a lot to the material presentation.
Absolutely. Yeah.
All right. So this worked. This is great. And now, what if you want to render a turntable, right? You notice, guys, when the camera flies around the object or the object rotates in position. You can actually do this with InstaMAT as well, and it's super easy to do. And I think there's two different nodes we have for this. One is set viewport camera. So if you use this node, you can actually set the camera position using the node itself. So we can set up the position and the orientation here. So let's see. As you guys can see, if I rotate this here, my camera actually looks around, so you can change the roll of the camera. I'm not sure where my object is.
I think it's because it's in the center of the world.
Oh, right, so we have to move back a little bit. Thank you. So, right, so you see, if I move the camera back here by 70 units, we can see our object here in the scene, and I can also change the field of view. I could modify the exposure. Enable or disable automatic exposure. So all of these parameters can then be animated in the same way. But if you want to create a turntable, there's a node that's a bit easier, because here you could do the math to figure out the position for your camera and the orientation to have it do an orbit around the object. But what's actually a bit easier is if you use the viewport orbit node here. It's called set viewport camera orbit position, and this basically allows you to easily set the orbit position here, and you can see if I change that, it's actually doing a orbit around the object. And in this case, it actually looks a bit funny because we have a hemisphere and not a full sphere. So I'm going to change this to a full sphere, and then I can perfectly orbit.
Yeah, this node is fantastic, and I use it all the time for just, even when we do some of our explainers and videos, I render out things straight out of InstaMAT just to see exactly what you get, and I use this all the time because it's very handy. And the fact that you can control all of the different camera properties and parameters through a node is also very powerful, because then you can set specific camera angles and things when you're doing design reviews, for example. So not even just for animations, but then you can make sure that anytime someone opens this graph, they're going to see an asset from a particular angle. If you're doing like an isometric video game and you want to make sure you're getting the exact camera angle that you're going to see in game, you could set that up here as a preset, and then your viewport camera will snap to it automatically.
Absolutely, very useful feature that you can also modify the environment rotation and the opacity here. This allows you to create some pretty nice renders. So let's try to render a turntable, and as you guys can imagine, this is very easy. All I have to do is expose the camera orbit position, right click, expose, and then I can modify the parameter here through my main graph. Let's rename the graph actually to dope sheet demo and save that on my desktop. And then I can just keyframe in the same way. So in the first frame, I set it to 0, right click, add a keyframe to my dope sheet, and you can see it appear down here. Let's make that a bit bigger. Then I go to the last frame because I want this to loop. So I'll make sure that the values in the beginning and the end are exactly the same. Add another keyframe here, and then I'll go to the middle frame. And here I can just set my, so it's 100% at the same location, Jeremy?
It'll do a full loop, so I think you just
right,
do
so
a start
it's a bit
and end
easier
keyframe.
then, right? So
Yeah,
that makes sense that we did it like this. So I'm going to set the middle frame actually to 50, add a keyframe. And if I would play this back now, it wouldn't be what you guys expect, right? If you would render this, you would expect the motion to be in one direction, right? But what you're actually seeing instead, and I'm going to disable the playback capture this time if I play this. So what you're going to see here instead is that we're going to actually rotate in one direction, and then we're going to rotate back. And the reason is because the last frame we're going back to 0 with our camera orbit position, but what we actually want to do here is go back to 1 or set all the way to 100 so the camera continues to do the 360-degree loop around the object. So let's update the value in the dope sheet and then play that again. So we have a continuous motion here. It actually slows down a little bit in the middle point, and that is because we have the easing, right? So if you look at this now, because we can just go from 0 to 100, we can, there's two different ways to fix this. So one, you could now align this handle with this handle and then this handle with this point to make it more linear in the middle. But you can also just remove the keyframe here. We actually don't need that. So just deleting it, because we can go straight from 0 to 100. And if we play this again, it's now going to be a very nice animation with a bit of slowdown, actually. Do we have shorthands where we can just...
Yes. Well, we don't yet, but what we can do is we can connect the pins in the middle, basically, or the same kind of trick.
Yeah, so you basically drag your handle onto one point here, down here, and you drag the lower handle onto the other point. What you essentially do is you linearize your interpolation. I haven't done that super precise, but it might be good enough for us to just get a linear motion out of our turntable. But it could actually be nice to also have some easing, right, when you have a looping video where it just slows down at the center and then it spins back again.
Yeah, if there's a part of the material that you want to feature or the asset particularly that you want to spend a little time on, that's also a good use case.
All right, let's render this out. Yeah, there's quite a lot of things you guys can do with this ability to have the dope sheet in InstaMAT, from exploring your material and see how the different parameters evolve the material, to rendering the material itself, to doing these turntables and so much more. And we might be able to show you a few more things you can do here. So let's see, which one is it? It's this one, dope sheet demo. So if we play this, you see we get a turntable that just keeps turntabling. And we should probably loop this so it stopped turntabling. But we're back. So this is spinning and it keeps spinning. So very nice. No other tool needed. This works as is. And keep in mind, you can render this at any resolution with any configuration, and the node that you have right here would take care of setting up everything that you would want. And by the way, guys, if you want to build your own HDRIs, you can actually do that in InstaMAT. We might be able to show you this in another live stream session, but just keep in mind, you have a lot of, if you want to be adventurous and explore this on your own, there's a lot of different HDRI nodes that allow you to build some pretty nice looking HDRIs. Right now you can't directly use them in the viewport. You have to export them as EXR and then load them into InstaMAT separately. But you can
the HDRI tools are fantastic because you really have full control over where you're putting your lighting. I mean, if you have very specific, product visualization, goals, and you have, or you have an environment that you're using to base the lighting on the game that you're working on, things like that, you can easily, just create your own, and really you can even keyframe these kinds of nodes as well if you want the lights to move in a particular way. It's pretty powerful.
Yeah, as you guys can see, there's a lot of nodes that you can just stack together. And then if you would use a node like mesh render, I think you should be able to just plug that HDRI in. If you go to image-based lighting and then you use input map, you can now plug in your HDRI into the input map. And you guys can see here, it's actually rendering this HDRI that we just composed in the viewport right in your mesh render node. And we want to add better workflows and UX around this, but like this, it already allows you to do some pretty cool things here in the graph directly.
Yeah, the mesh render node and the scene render nodes, all the render nodes built into InstaMAT are also probably something we could dive into in the future as well. It's another great way to create stills and different type of design review workflows as well.
Yeah, one more thing I want to show you guys is how you could actually render this without using the viewport, because you're not just limited to bouncing or rendering your viewport render. You can actually render the image that you see in the image viewer. This allows you to do some pretty cool things. For instance, if you want to animate your normal map that you then use in a game, for instance, you could just change the capture source from viewport to image viewer and then hit the play button, and it's then going to bake out the animation that you have in the image viewer as a result from all of the dope sheet. So the dope sheet doesn't just affect the viewport, it actually affects the graph execution itself. As you guys see, the material inflates and deflates, but it also affects what you see in the image viewer right here. So this bounced, and here we have our new video file, and as you guys can see, if I animate this, you can see how the folds on a normal map disappear. I can probably make this a bit easier to see if I double the playback speed. You guys can see no normal map, wrinkles, and then in the beginning you have the wrinkles again. So, and with this, knowing this, you might already know what you could then animate. You could, for instance, use a node like mesh render. And this time I'm going to take what Jeremy mentioned. I'm going to use the link category mode to plug in my material from my material node into my mesh render node. So I'm going to drag from here to the material input, and now we can see it in the node result. I mean, it looks very similar, but what you guys have to imagine that what we have here is not a 3D viewport scene. This is now a image, so we can just zoom in here and you can see the alpha background here. So this is an absolutely standard 2D image, and we can control which mesh we're rendering. So let's see what we can use here as input, so it's a bit different from the viewport. So on the meshes, let's see what we have here. Maybe use the bevel cube, right? So I'll take my bevel cube and then just plug that guy into here. And as you guys can see, it updates here. Let's change the environment rotation like this. And if you would animate this, let's rotate it a little bit. And if we animated this and capture our viewport now, this is actually what we would see. So you could do a couple of mesh renders and then compose them together. For instance, I'll just duplicate this here. And now we're going to change the perspective slightly. Maybe get much closer. Like this. So, and what we can do next is do a compose, right? We could just blend those side by side. I guess it makes sense. So what we're going to do is we take a blend node and we're going to create a opacity mask for this using our shape generator in grayscale mode, where we're going to be using a rectangle to mask off half of our image. Just very much an approximation like this. Actually, I want this on the right side. Something like this. And now I'm using this mask to combine the cube as the left side or the right side actually as background. And then the foreground is going to be the other side of our cube, like this. I mean, it doesn't look super great as is, but I think it's going to do exactly what I want. Can we move this a bit around like this so it fully covers? And then maybe we can move this guy more like this. You can also scale it down. Well, it clips into the camera.
Oh, yeah.
The near plane, we can move the camera back. Maybe that works. It still clips into the near plane. So maybe we'll just do this. And then instead of doing it in the 3D scene, we can use a transform and then manually just transform the object to the left side and set up a background as well. This shouldn't be transparent. So I'm going to right click here, increase the opacity and maybe black or color. I guess black.
This is cool. The workflow that you're doing right now is a compositing workflow that you might find in other applications to do just common video compositing. And you can do it here with nodes right here in the element graph. And remember, this is the same graph that you can use that we just did, previously to scatter objects or create materials. And now we're creating a compositing graph in the element graph to be able to render out things. It's pretty wild what you can do.
Exactly. So now this timeline animates the viewport, as you guys can see up here, but it's also going to be animating the material that we use down here, update the composition, etc., etc. So once I'm going back to my timeline, we have capture enabled, so I'll hit play. This is going to do exactly what Jeremy mentioned. It's going to be doing some really sophisticated compositing of the previous results. So imagine the kind of workflows you can build and then quickly create the design review artifact that you need to show to your art director to get approval on your material. I think that's a really fantastic workflow.
Yeah, and I've actually got a question too. So we're working in a typical square resolution right now that you would have for building textures. Could we also show them how they might be able to create something more like a wider aspect ratio, like a 16:9 kind of thing? I think many people are probably going to be curious about that too.
Yeah, I mean, you can just change the render resolution that you're executing at, right? Because whatever you have in the viewport, that's what you're going to be exporting. So for instance, if you want to change one node's aspect ratio, you could just go into this node and then basically just modify whatever aspect ratio you want. So maybe if you want half height like this, it would work. But you have to make sure that your input images are correct. I think we have some nodes for this specifically, like aspect safe placement, that makes sure that your aspect ratio remains the same. But I think even our blend node has the aspect fit and the aspect fill that you can use, that just takes care of the positioning of some specific elements in the scene.
Yeah, great. Thanks for showing that.
All right. So it's quite a lot already. How much time do we have on the clock? It's already probably close to 1 hour. 45 minutes. That's pretty good. We're pretty good on time. So maybe we can run through a few questions that we have or some other points that we have to discuss today. Jeremy, do you have something on your list?
Yeah, I can go ahead and pull up some questions here. So far, anyone watching right now, if you have some questions, feel free to add them straight into the chat here. Otherwise, there's some questions that we found, some on our YouTube videos.
Yeah.
So, actually, recently we've covered a bunch of UV unwrapping techniques on our YouTube channel. I can go ahead and, ask one of the questions about UVs here that we have from one of our users.
Yeah, I do think I have the list as well, so I can just read the question. Hey, guys, I love what you're doing with InstaMAT. Just want to check if there's any way to view the UV in a separate viewport, and is it possible to paint in the UV viewport like we can do in the 3D viewport? If it's not available yet, I hope it will be available in future versions, as it's an important feature. I mean, I don't have an asset texturing project open right here, but I can quickly open our sample project here for InstaMAT's asset texturing. 2D painting, maybe that question is easy to answer. 2D painting is not yet available, but if you want to open up a 2D view of your material, you can just right click on the layer you want to see the compositing for and then choose the view composite output for current channel here. And then you can see your compositing output. And what's pretty nice is if you change something on your material, like if I change the HCl here, you would see that immediately. And what's also very nice is you can actually have multiple tabs open at multiple different stages of your compositing. For instance, here's the dirt rainy. If I enable this, you can see the viewport updating with the rain here, but we don't see it here because we preview the material output. But I can also choose to output this layer in a new tab right here. And now you have both of those open available at the same time. So if I would change the blend of my dirt, you guys can see that it's way less visible. And there's some other cool features you have, like being able to do a side-by-side view. If you right-click and then compare this to the current tab, you can see you can even overlay to precisely understand the changes that happen as part of the compositing of all of the different layers that you have.
Right. Yeah, and is it possible to pop this particular panel off from the UI, or is that something that we have for different layouts?
This is not yet possible. We have that for the element graph where you could pop out the image view. Here it's integrated right now. It's the center of your application here, the texturing project. So these are fixed. You can pop off the side panels, but the center part is fixed. What you can do is you can rotate it. If you just need it, shouldn't take too much space, and you just want to peek at a few pixels, you can just dock it horizontally or vertically in this case, and it'll take up less screen real estate. We will add painting. Painting is not yet possible. We understand that it's very important for asset texturing. It's something that will be available in the next, or maybe the one following the next release. So we didn't forget about it. We understand that it's pretty important. So let me see about the next question. What do we have? Thank you so much for the video. I'm especially interested in the graph element, atom, and nPass. Unfortunately, the last two received very little attention. I mean, I think we did 2 or 3 sessions already on the element graph, right? Didn't we do an atom graph example already,
did
Jeremy?
A filter, right, where we could create a pixelation filter. I want a stream not too long ago. I recommend anybody who's interested in building sort of those lower level, image processing nodes, check out that stream. Maybe we can link it below as well to direct them to it. But it's a great way. It covers the entire how atom graphs work and how to be able to build your own filters, not only just as nodes, but how you can use them inside of other projects. So yeah,
it's super powerful. I mean, there's so much you have in InstaMAT, and I think that's one of the issues of building one application that can do it all, right? That it's very difficult to build content in a way that's also easy to find for people, because we did a couple of videos on the atom graph and the nPass graph, but I guess it's part of the overall educational material that we're producing. So maybe we can improve, the way that content is being discovered. But we will do some videos. Just keep watching the live stream and let us know what you guys want to see. I think doing one on nPass would make sense to show people what you can do with the nPass graph. That's for sure. Maybe some more atom graph things, some of the secrets, some of the non-obvious things.
I think it's a great idea. Yeah, the nPass graph is really crazy. I mean, the fact that you can, do everything that you can do with an element graph, but then, repeat things over and over again and create simulations and scatters. So yeah, there's an introductory video that we have for that now, but I think that'd be a great topic to cover in the future.
Absolutely. There's actually another question here. I also want to point out that the step parameter, it gets very technical, guys, but I'm just kind of going to keep reading. I also want to point out that the step parameter hasn't been added to the variable settings. I presume this is about the nPass graph, right? Where you do multiple iterations, and as it goes from one iteration, it goes to the next iteration, it increases a variable. I think it's called the pass index or something like this. And that's what you use mostly to drive your functionality. And I think the complaint here is that you cannot modify it. So he keeps writing, this is sometimes very important, as it allows you to change values not uniformly like 1, 2, 3, but for example in increments of 3. It's another one of those secrets. You can actually do that. You can just change the pass index that you're in, assign a number, and then reassign it to the pass index at the end of your iteration. That actually works. So you can do this, and it's actually even more powerful than being able to say, hey, my step is always 2 or it's always 4, because you can do a dynamic step. And if you want to terminate your nPass execution, what you can actually do as well is just set it to the pass count value itself. So if you assign the pass count to the pass index, it stops the termination. So you can create nPass graphs that run as long as they have to until they, culminate in, or the convolution is finished, and you abort based on some internal criteria. You can do that.
Very cool. Wow, very technical question.
Yeah, it is.
But it's pretty cool that you can do all kinds of stuff like that in InstaMAT, from the very simple painting all the way down to really, programming your own very specific simulations.
More questions, guys.
Let's go.
I can import. This is a bit broken English, but I'll try my best. I can import use to. I have to rephrase. So I'm paraphrasing here, guys. Can I import InstaMAT to competitor material software? or smart materials from the competition, from my collection of competition type materials. This is not possible right now, right? That's not, we really don't, we can't control that, because whatever the competition is doing is they have their own file format, and it's not open. If it's open, it would be easy for us to import or export or create some kind of an interchange between the different software packages, but because it's closed, there's not much we can do. But most of the workflows translate easily, and you can keep both applications installed on your hard drive. There's nothing speaks against it, and you use whatever you need. Both have integrations, so it's very easy to use both at the same time. And if you want to migrate your material from the competition to InstaMAT, what I would recommend you guys is to just export them at a high resolution like 4K or even 8K if these guys can do it, or 16K, and then just wrap it in a material make note, so you can always then use it in InstaMAT when you're texturing. I think that's an easy way of doing it.
We actually have a tutorial on how to do that on our YouTube channel, where you can bring in textures from a material, whether it came from a competing software or it's something you've downloaded, or even materials from Polyverse, and you can actually bring them into the element graph and then use material or image synthesis to create new variations of materials that start off as those maps. So if you're looking for some procedural functionality from a material that you've gotten somewhere else that's made from images, you can actually add some proceduralism to those materials by using the image synthesis nodes. And you can check out on our YouTube channel. I'll have to remember to link that down on our description as well. It's a great way to be able to expand your library.
It's good to have you back, Jeremy. You talk so long. I always have pause to drink, and
Oh, good.
Make sure my throat is not too dry. So another question that relates to you as well, Jeremy. Where can I buy your beautiful hoodie? I want one. This is, Jeremy is wearing one of our beautiful abstract hoodies. These are not yet, you can't buy those. If you want one, you have to participate in November in order to get one of our beautiful hoodies, or visit us at one of our conferences. We sometimes have those hoodies. And then let us know that you saw us on the stream and we talked about this. Maybe you get one of our hoodies for free. I can't guarantee you, but maybe there's a chance for you to get one if we have one on site. And then the next question is about, what is this? 3D mouse support, space mouse support, question mark. That's all I have here. Space mouse support.
I think people are just curious if we have, if we're looking into, space mouse support for InstaMAT.
Yeah, I get it. I mean, it's really important to us. It's high on our list. We have the hardware here on site, but we just don't have the resources to look into it right now. One way to support us, guys, is to hit the like button, hit subscribe, and all the bells and whistles you have to hit, but also buy a license. This helps us massively to make sure we have the development resources in order to add all of those features that we really want to add. It's not like we see the space mouse and know you guys like it, and then we're like, no, the space mouse, no, we're not gonna support that because people like it. No, we want to support it, guys, but you have to support us so we have more resources and can work on all of that stuff in parallel. And then, yeah, I think we just conclude here with the community questions. There's quite a lot.
Sure. Yeah, I was just going to say, if you guys do have features that you are looking for, always reach out with questions. Contact us on Discord. Reach out on X or LinkedIn. But also, you can create feature requests on our community forum. Right? You can make a feature request, and then what's cool about that is that other people in the community can add their votes to those features, and it allows the developers and the team to see what features the community is broadly interested in. You can add those votes on, and then who knows? You might see it one day appear in InstaMAT or in one of our software applications.
Absolutely. Support us, guys. We need the support. We're not big corporate. This can't be said more often, right? Because people do believe the software is so powerful, and they look at what we're doing and they think we're like Adobe or Microsoft, and we have infinite resources. We have finite resources. We have a finite team. We're just people. We're humans. So we need your support, guys. I guess that's it for today. Jeremy, I think we can wrap up. We did a good job. Thank you so much for being here, Jeremy. Thank you so much for tuning in to Abstract Live today, guys. I'll see you in the next show, and stay tuned for more. Bye-bye.